Okay, find slope using a graph or table. We have already looked at finding slope in two different situations. One of the situations we had a diagram. It was the diagram or the image of the treadmill, and we were able to determine the rise and the run by looking at the diagram. The other situation we had was a word problem or a paragraph, and we had to comprehend. We had to read and find out in the paragraph what the rise would have been and what the run would have been. And we have to look for cues. Sometimes they say, hey, it's the rise. Sometimes they'll say something like horizontal change. So we were done with that. We want to remember that slope is a rate of change, okay? We're trying to find a rate of change. So it's going to be very similar to finding the constant rate of change. It is also important to remember that a slope can be positive or negative. Okay, the new way of trying to find a slope is now by looking at a graph. We talked earlier about how to do this, and what you're going to do is you're going to draw a step. All right, you're going to draw a vertical line and a horizontal line from one point to another. So if you can see the example here, we've got a point here. We're going to draw a vertical line all the way up until we're level with the other point, and then we're going to draw a horizontal line over. Okay? And now we're going to count. Well, how far did we travel up the y-axis? And going up the y-axis would be the rise. Now, if we look at the units, we're going up by 1, 2, 3, and 4. So we're going up by 1 each time. So we're going to count by ones. So I'm going to go up 1 and then 2. So my rise is 2. The run, we do the same thing. I know run is horizontal, so it's going to be along the x-axis or left to right. And we can see, also counting by ones, that I only go over 1 unit, so my run is 1. So my rise over run is 2 over 1, which means my slope equals 2. Are there any questions with how to do this one? We look at 2 points on a graph. All right, we take any 2 points on the line, and remember, any 2 points that I choose on that line is still going to give me the same answer. I'm still going to have the same slope. So I pick 2 points, I draw a vertical line and a horizontal line to get from one to the other, and then I see what the rise and the run is. Yes, Madison. Madison asked a very good question. If we have more than 2 points, do we have to choose the ones that are next to each other? And the answer is no. I can choose any 2 points on the line. Let's demonstrate that real quick. Let's say I choose to start here and draw a vertical line up and then a vertical line over. Okay? Well, let's count. I got 1, 2, 3, 4, 5, 6, and I've got 1, 2, 3. So now my rise over run is 6 over 3, which also equals 2, which is the same as we got right here. So because the line is straight, the slope for the entire line is always the same. It does not matter what points you choose. You can mix and match, choose any ones that you want. Excellent question. Okay, let's try another example. Now, before we go on, tell me what you notice about the line in the original problem and the line in this problem. What do you think, Cedric? All right, they are. Very good, Cedric. One is going up, right? And one is going down. All right? So this one, which is traveling up, do you think this will have a positive? Did it have a positive or negative slope? It was positive. So if it looks like it's going uphill, it's going to have a positive slope. All right? This one over here, which appears to be going downhill, all right, what do you think that we can determine about the slope? It's going to have a negative slope. Very good. So one nice thing about graphs is you can just look at it and know if it's linear. You can just look at it, know it's proportional, but you can also look at it and know whether it's positive or negative. Now, which one of these graphs is proportional? All right, the first one, meaning the first one we looked at. How can you tell that this is proportional? Very good, Morgan. This line travels through the origin. We know it's proportional. What about this one? The next one does not. We see the origin down here, and the line is not going through that point, okay? All right, so once again, I know this is going to be negative. Here's why it's negative. Because when I draw my step in, I have to go down. So I go down 3, and then I go over 1. So I have negative 3 over 1. So my slope is negative 3, okay? So that is how we find the slope or the rise over run from a graph. Now, there is another way that we need to be able to do this, okay? Let me clear these answers from earlier so y'all don't cheat, especially Lay. Okay, so now I have a good old-fashioned table, and finding the slope is very similar to earlier when we found the constant rate of change from a table. Notice this one tells us it's the y. The y-axis, is that the rise or the run? It is the rise, right? The y-axis is up and down. So I'm going to label this just to keep it straight in my head. Okay, the y is the rise. So what's going on here every time? I'm going from 12 to 9, 9 to 6, 6 to 3. Very good. So I'm going down by 3. So I know my rise is negative 3. What about my run? Adding 2. Very good. So my run is 2. So my slope that I have just determined from this table is negative 3/2. All right? Notice I find the slope the exact same way that I find the constant rate of change. It's the change in y, or the vertical change, the rise, over the change in x, which is the horizontal change, or the run. Okay? Let's do one more. Okay? Notice in this one, I've already kind of got it labeled for you. The room's painted and gallons of paint. Well, what depends on what? Well, does the paint depend on how many rooms you painted? Or does the number of rooms you can paint depend on how much paint you have? Right? So the number of rooms that you can paint depends on how much paint you have. So that means the rooms painted will be dependent, which means it would be the y-axis, which means it will be the rise. The rise. There you go. Third time's the charm. All right, so what's going on with the rise? All right, adding 3 each time. What's going on with the run? Adding 2. Okay, so I notice that my rise is 3 and my run is 2 in this situation. Okay, now let me ask you this. In this one, my slope is 3 over 2. In this one over here, my slope was negative 2. How are those lines going to look different on a graph? What do you think, Madison? Okay. This one is positive, right? So it's going to look like it's going uphill. This one's negative, so it's going to look like it's going downhill. All right, very good job. Okay, there is another got it. There's got it B and C in the middle of page 183. Please do that now. B and C on 183.